Hi everyone, my name is Victor and I'm one of the authors of TechNeed. In today's lesson, we're going to be looking at what Istio is and how to configure and use Istio in Kubernetes. But first, what exactly is this Istio? Istio is a service mesh. And now you might be thinking that what is a service mesh? To break this down clearly and to understand what Istio is from scratch, let's even understand the word mesh itself. Mesh is it's a dictionary word, it's in your dictionary, and when you check what mesh means that everything is connected to everything. And in that case, if we say that everything is connected to everything, then it is safe to say that a network mesh means that every network devices are connected to each other. They are interconnected. They are meshed together. Similarly, a storage mesh would mean that all storage devices are connected together. They are linked together, they are meshed together. And now in our case, if we say that Istio is a service mesh, it means that a service mesh means that all your microservices are connected to each other. They can talk to one another. And not just anyhow, they communicate in a secure, reliable, and in a controlled manner. It's like giving every service a walkie-talkie and a shared rulebook. No guesswork, it's final, right? So that is what a service mesh is. And now, why do we need a service mesh in Kubernetes? In a microservice architecture, you can have dozens and even hundreds of services talking to each other. And now here's the issue. Every service has to undo retries. They need to undo, every service has to undo timeout. They need to be encrypted. The traffic needs to be encrypted amongst the services. You need to authenticate requests. You need to collect metrics for observability. You need to undo failures and a lot more. And trust me, that's a lot of work to do for developers. Imagine a developer having to write all these communication logics. That is heavy duty coding. I'm not a developer, but I know I edit scripts and I know what it is to have to put all those things together, right? So having to write those logics over and over is not efficient. As a matter of fact, it's risky. And that's where Istio comes in. So with Istio and with even other service meshes, Istio is not the only service mesh we have. We have other service meshes like the link card, the console, the Coma, the AWS app mesh, right? So with a service mesh, that all those logics would be taken care of. And how does Istio work? So with Istio uses something rather called a sidecar. So a sidecar is a small proxy which can also be called an envoy proxy, and that envoy proxy are going to be injected in each microservices. So those proxies will be the one to now handle the communication logics. They'll be the one to handle communication between services, the TLS encryption, traffic routing, load balancing, observability, access control, and any other logic developers should not worry about. So that's what the Envoy proxy would do. So now here is the catch. If you have the Envoy proxies being injected, or if you have them sitting inside of each services, it then means that those Envoy proxies will then communicate with each other. So a service would not talk directly to a service, they would talk with the envoy proxy. So instead of a service A talking to a service B, the envoy proxy in service A will talk to the envoy proxy in service B. So that is just too simple, smooth, clean, and efficient. Now that I've explained all of this concept, now let's go back to what Istio is again, right? Let's define Istio clearly again. So Istio is one of the most popular service mesh implementations. Basically, that's it. And like I've said, we've mentioned what it provides. It provides advanced traffic control. Like so when we say advanced traffic control, we talk about canary deployment, traffic shifting, which is also known as canary deployment. So with Istio, you can actually do canary deployment. With Istio, it provides security, like we've mentioned, traffic encryption. With the Istio, you can have observability, your metrics, your tracing, your logs. You know, that's the the essence of having Istio. And like I've also mentioned that the one cool feature about Istio is the canary deployment, which means that you can route just 10% of your traffic to a new version of your application. And when you then test and you're satisfied that the new version is fine, then you can route the old percentage, that's the 100 percentage, to that new version. And if it's not fine, you can easily roll back. And that's why Canary deployment is one of the best deployment out there. In this lesson, we're also going to look at, deploying application using Canary deployment. Another component of Istio is the Istio gateway, which is also called Istio Istio ingress gateway. And basically, it's an entry point into the Kubernetes cluster. So you can think of this as an alternative to the common Nginx ingress controller. So you can either use the Nginx or any other ingress controller to expose your application to the outside world, and you can also use Istio gateway as well. So whichever one you use works, and we're going to also look at how to use Istio to expose applications. We in our previous lesson we looked at how to use Ingress to do that, but in this lesson we're going to look at how to use Istio to also expose applications. So having understood what Istio is and what service mesh is, let's get to the demo immediately. All right. So before we look at installing the Istio, there's something I need to also mention, which is we need to look at how to inject Istio sidecars to pods. Like I've mentioned that the sidecars, which is also the envoy proxy, they need to sit inside the pods. So there are three ways in which you can make the envoy proxy sit inside the pod or inject the envoy proxy inside the pod. So you can either use a namespace based automatic injection, which is also the recommended way. And that means that when you're creating your namespace, you need to add this label saying that you want Istio to be, you want the Envoy proxy to be injected into every pod that is created in this namespace. So that's what you're basically saying. And the other method is the pod level injection label, and the third one is the manual sidecar injection. So I'm going to be sharing the link to this description, the link to this to this documentation in the description box below, so you can also check it out. Yeah, so let's go to the step-by-step guide of how to install Istio on Kubernetes cluster. You can use mchart and you can also use a direct apply method, but we're going to be using the mchart here. And yeah, to say I've installed Istio, so but again, I'm going to be demonstrating the step-by-step guide. And the first step is to download the Istio release bundle locally. And by using this command, you will be able to download that. And the next step is to extract. So if you look at, I don't know where I put this, but let me do ls. Okay, yeah. So when I downloaded it, yeah, this was the file. So if I run this command, it's going to download the Istio. Like I said, I've done it already. So you're going to have this file here. Then when you extract, when you download, you need to extract. And when you extract, you're also going to see this here, which is the Istio 1.24.3. And this is what you see when you download. And this is what you see when you extract. Yeah, so the next thing you need to do is to then change directory to the file that has been extracted. So this is it's a directory rather. So you need to change directory to this Istio. Yeah, and then when you do that, yeah, so you're gonna find the different charts. Yeah, you're gonna see the tools and everything you need to see here. You can list, which I've also done here. And from this side of the directory, you can then install the Istio based M chart. So whenever you're installing Istio, you need to install the Istio based chart, and then you also need to install the Istio D chart. So for the Istio based M chart, that contains the necessary CRDs that the Istio D needs. And by using this command, right, you're going to install the Istio based M chart. And when you install it, this is what you get at the end of everything. You get the name, the last deployed, and you can also verify that the necessary CRDs have been installed. If I copy this command, definitely I can verify that here. So you can see the necessary CRDs, there are a lot of them. Yeah. And that's step 6. And for step 7, you can then install the Istio DM chart. So the Istio DM chart is the Istio controller itself and the engine itself. So you can just use the same M command, right, to install Istio. And when you install Istio, this is what you're going to get. And you can also verify that the Istio pod is running. So let's do that. I can just clear my screen here and then run this command. So you can see that the Istio pod is running. So I did this deployment 29 days ago. Yeah, basically. So the Istio controller is running, and the next step is to, yeah, we're ready to start managing traffic using the Istio control plane. Yeah, and the next step is to install the Istio Ingress Gateway. I also talked about the Istio Ingress Gateway, which is a way of exposing the applications to the internet or to the external world. And that is, if you don't want to use Ingress, you can also use the Istio. That's if you don't want to use Nginx Ingress, you can also use the Istio Ingress Gateway. And in the previous lesson, we looked at how to use Ingress to expose applications to the outside world. And in this lesson, we're also going to look at how to use Istio to expose applications to the outside world. So basically, this is how you're going to install the Istio systems on your Kubernetes cluster. All right, so let's quickly talk about this Istio Ingress Gateway. Yeah. So when you install the Istio Ingress Gateway, you also need to verify that the pod is running, right? Of course, I have it that it is running here. You see that it is running, and the next thing you need to do is to verify that the Ingress Gateway service is also being deployed or created. And if I do that, you can see here that it's also being created. When you do that for the first time, your external IP here is going to be pending. And if you look at what I have here, you can see that it is in a pending state. And it is in pending state because we don't have, this is an on-premise Kubernetes, so we don't have the cloud controller manager. So what the cloud controller manager does is that it listens to any service type called load balancer, and then it automatically assigns IP or a DNS to this service type. and that can only be achieved on cloud managed Kubernetes services like AWS and Azure. And since this is an on premise environment, you need to look for an alternative. And the alternative is to use the meta load balancer. In the previous lesson, we also talked about when we're looking at using ingress to expose the applications to the outside world. I also we, I also we also looked at how to install Meta Load Balancer. It's in the video. It's also in this documentation. So I'll be dropping the link to this documentation and the link to the previous lessons video in the description box below. So you can also check that out. And as soon as you install your Meta Load Balancer and you try to get service again, you're going to see that an IP has been assigned. So this is how you're going to install the Istio system on the Kubernetes. So we've basically installed two components. We've installed the Istio D component and we've also installed the Istio Ingress Gateway component. And don't forget, we needed some CRDs to be able to install these two components. And those CRD that we needed were in the Istio base M chart. So yeah, having understood this, then now let's look at the step-by-step guide of how to configure a microservice application to use Istio. And we're going to start with the Canary type of deployment. For clarity, this exercise or this demo is going to be divided into four parts. So we have part A to part D. So let's start with the part A. So in part A, we're going to deploy a Go application, and that is going to be the version 1 of that application. And we're also going to create a namespace, right? So if you look at the YAML manifest to create a namespace, we're going to be creating a namespace prod, and then we have the label Istio injection enabled here, meaning that every pod we create in this namespace would have the Envoy proxy injected in them. And we're also going to create the deployment resource, and you can see the deployment manifest file. The name of the application is going to be Go App version 1 because we are assuming that this is the first time we're deploying this application. And if you look at the image is going to be pulled from the Techniques Docker registry. You can also pull the image from here as well if you want to. It's free. And the next YAML manifest file is the service. So we're also going to be creating the service resource with the name Go App. And we're also going to be creating, so basically for this Go App application, we need to create the deployment resource and the service resource, and also the namespace, which I've shown you, namespace, deployment, and service. Yeah, but so because we are not exposing this application to the external world yet, we need to be able to test that the application works fine. And because we also want to do some testing, we want to do a Canary deployment and we need to start testing. So we need a test pod to be able to do that for us. And the test pod is going to be created in the backend namespace. And the name of the pod is going to be client. And we're also going to create the test pod resource. So if you combine all the resources together, you're going to have it as one here. So I'm just going to copy this file and I'm going to create the file and then we're going to deploy this file. So this is BI. Let me just drag this away here. Don't know how I can close this, but let me just move this somewhere here. No, somewhere here. Can I exit? Okay, I can exit. All right, so just gonna say vi go up dash version 1, and I can say enter. Can copy in all this file here, and so we can deploy this application. So I can say kubectl apply file go up, and you can see that the different resources have been created. The namespace has been created, deployment has been created, the service has been created, and the namespace for the test pod has been created as well. And the pod has also been created. So if I do kubectl get pods in the namespace production, so you can see that the pod is running. And if I also want to look at the namespace backend for the test pod, you can also see that the pod is running, and you can see 2/2, meaning that there is another container, which is the envoy proxy, inside of this pod. So you're having two containers, one container for the normal application and the second container for the envoy proxy. The same thing is also applicable for the test pod. All right. Now that we've been able to do that, and the next thing we're going to do is we can now start testing with the test pod. So let's use the test pod to verify where the traffic is being routed to. Like I mentioned that the test pod is used for testing, right? It would continuously send requests to the Go app service. That's what the pod does. And to do that, I'm just going to scroll down here. Okay, so we can connect to the pod. So I can just do this and connect to the pod. Copy this command, paste it here. So we can see that I'm in already. So I'm going to run the script to continuously send requests to the Go app service. And before I run the scripts, let's even do this first. Let me just do call. Let's run this command first so you can see the output of the application. It's like I said, it's just for test purposes. So it means that whenever we expose the application to the outside world and we browse over the internet or over the browser or any of your browser, this is what you're going to get. But now we need to run this script. This script would continuously send requests. So we're trying to see we're trying to see which we're trying to test where the traffic is being routed to, basically. So if I copy this guy and paste it here, so you can see that this is running continuously and the traffic is being routed to version 1. So like I said, we're just assuming that this is the first time of deploying this application, and then we have version 1 of this application. So we are cool, we're fine. So now let's say there is a new feature of this application, there is an update, and we want to deploy this application without causing downtime. We can leverage on the Istio's traffic shifting capability, which is also known as Canary deployment. And Istio uses two key custom resources when it comes to Canary deployment. So those resources are called the destination rule and the virtual service. So for the destination rule, that tells Istio about the different versions you have, meaning you have version 1, you have version 2. It's also called subsets. And for the virtual service, that is how you're going to define how you would route traffic to those two different versions of your applications. So whenever you're using traffic shifting, which is also known as Canary deployment, what you're saying basically is that you already have your version 1 of the application, and you want to deploy version 2 and you want to systematically do that. So what you can do is this: you would then point traffic to version 2, let's say 20% of the traffic, you already have 100% of your traffic being pointed to version 1. But now that you're bringing in version 2, you're not sure of how it is going to look like in the market. You're not sure of how people are going to react to it. You're not sure of the problems of version 2. So what you can do is that you can now route 20% of the traffic, to version 2, meaning that version 1 would have 80% of the traffic and version 2 would have 20% of the traffic. So maybe people in some region, say people in the western region, for example, they can then, be using version 2, or maybe some set of people that are supposed to test how version 2 works. Since you already have 20% of the traffic routed to version 2, they can then test version 2. So if it works out well, you can then route the 100% of the traffic from, you can then move the remaining 80% of the traffic from version 1. You can then, route 100% of the traffic to version 2. So that's it basically. That's about Canary deployment. So for version 2, this is the deployment manifest file, and the name is go app version 2. And for the image, the image for version 1 is 210. So because we now have a new version 2 application, so the image is going to be 211. That's go app-211. And of course, it's going to be one service. We already have the service being deployed already for the application. So we just need to deploy the new pod or the new container for the application. And like I mentioned, you need to use, when you're doing Canary type of deployment, you need destination rule and you need the virtual service. So if you look at the destination rule resource, you can see the name go up, you can see the host. This is going to be targeting the name of the service. And this is for version 1. So the subsets, this is for version 1, this is for version 2. And the virtual service resource, like I said, you're routing traffic. So what you're basically saying is that for subsets, that's for version 1, you're going to make sure that the traffic is at 80%, which has the highest traffic. And for version 2, right, you're routing 20% of the traffic to version 2. And that's what we're going to be doing now. So if you combine the deployment resource, the destination resource, and the virtual service resource together, we can combine it as one and then create these resources. So I'm just going to copy this as well. And oops, let me just copy from here. Let's copy this here. And then I can come here and say PI go up version 2. Can say enter, paste it here. And then I can say kubectl. Oh my god, I'm inside of the container. So I need to remove this. I'm doing this inside of the container. So I need to exit this guy and I can say vi go up version 2. So I can do this here. I can save and I can say kubectl apply file go up version 2. So now you can see that the deployment resource has been created, destination rule has been created, virtual service has been created. And trust me, we've started routing the traffic, 20% of the traffic to version 2. And how do I know that? So let's test. Before we test, let's verify that the version 2 pod is running. So I can do kubectl get pods namespace prod. So you can see that the second pod is running. Yeah, so basically let's now test. So what we're going to do is to go into the container and then we can run the script again. And we're going to know how the traffic is being routed. So if I run the script and okay, coming. Let me just clear my screen to exit. We're going to the container again and then on the script. So if you look at the screen, you can see that traffic has been routed to version 1 multiple times. And now there's a version 2 because it's 20 percentage, right? I'm just routing 20 percentage of that traffic. So version 2, you can see that more of the traffic is being routed to version 1. And this is how I can tell you that some of the traffic is being routed to version 1 and some of the traffic is being routed to version 2. And this is Canary type of deployment. So that would take us to the part C of this demo, which means that let me now say that, I'm now confident with version 2. I can then split the traffic evenly, right? So we can route 50% of the traffic to version 1, and we can also route 50% of the traffic to version 2. So I can just stop this, do exit, do clear. So I can go up version 2, and then I can say now I want to split the traffic evenly, so I can say 50% routed to version 1 and 50% routed to version 2. Can save this and do kubectl apply. I think I should have this command already. So kubectl apply version 2, and now I can test again. So I can enter into this container and then can copy the scripts and let's test again. Hey, what's happening here? Syntax error. I don't know. Let me just go and copy the script where I know I copied the first one from. Let me do this again. Okay, so let's see now. You can see that the traffic is being splitted evenly now. Version 1, version 2, version 1, version 2, version 1, version 2. So you can see that both version 1 and version 2 are coming here more often. They're being displayed more often, meaning that the traffic is being routed evenly. So now for the part C, or for the part D, I mean, let's now assume that we are now very, much satisfied that the version 2 of the application is working fine. Then we can route all traffic to version 2. And to be able to do that, I can stop this and I can just exit here. I can do vi go up. So here I can make the weight 100%, and here I can make the weight 0%. I can save the file and I can do kubectl apply again. Then and exec into the container, and I can run the script again. So you can now see that the old traffic is being routed to version 2. There is no version 1 any longer. And this is how you can make use of Canary or traffic shifting type of deployment using Istio. And the last part of this demo would be how to expose the Kubernetes application externally using the Istio ingress gateway. So I won't be doing much here, but I'll just, explain the things that I did here. So for you to be able to use the Istio ingress gateway, basically you need two resources, which one is the gateway resource and the other one is the virtual service resource. And just like we did in the previous lesson when we used the ingress and the ingress controller, right? So in this case, we're going to be using gateway and the virtual service. And for the same Go application that we've just deployed, if you want to create the manifest file for the gateway resource, you can do that. So this is an example of the manifest file for the gateway resource. So here we have the manifest file, and for the virtual service, what we just did was to update the parameters, some parameters, and you can see the parameters that were updated. And we then apply the manifest file, and then you can verify that the gateway has been created. And the next thing you're going to do is to apply the manifest file to update the virtual service resource. And then you can also verify that that has been created. And of course, you can allow whichever port your service is listening on, you need to allow that. And the next thing is you need to also configure the DNS resource, which that's the A record as against the IP. Like I said, we used the meta load balancer to get this IP. So, and then you can test your application, and then you can also test your application. And the next thing you're going to do, you can also check from the browser to test your application. And the application is not secured here. The next thing I did was to configure SSL for the application. So you're going to have to create a secret with the TLS certificate, and then you need to reapply. You need to reapply the gateway manifest file, and then you can test again, and then you would see that your application is secured. So basically, if you follow these steps, you'll be able to use the Istio gateway to expose applications to the external world. If you don't understand, let me know. I don't want to just go through this process again because I've gone through it before and I want to do so many videos. But if you know that you don't, or you didn't get the process and you want to also use the Istio gateway, let me know. I will take my time to do another video for this in particular, and I'm going to upload it. So thank you for watching. Please don't forget to subscribe, like, share. When you do this, you encourage us to do more of this video, and bye for now.